welcome back to yet another video on our channel Euclid Mathematics. We have started lecture series on ring theory. So already I explained plenty of the videos on my channel. If you wanted to see this video, you may go through my playlist. So in my today's video, I'm going to explain to you all one of the question which is from CSIR NET previous year question paper, which is completely based on irreducibility criteria. Okay, so I already explained the definition of reducibility criteria, and some of the tests that can be helpful to find out whether our polynomial reducible or irreducible. So now here I can taken one example which asked in a paper in second. It is for 3 marks. It is quite easy example. We just have to apply one important test, which is Einstein's reducibility criteria, in order to get the solution. Now let's get started our today's lecture. Now here we all can see I written here example, which is a f of x polynomial, integer polynomial, which is x cube plus 312 plus 123. Okay, so we have this polynomial. We have to check whether it is irreducible over q or not. Okay, as it seems like that quite confusing and difficult if we apply the definition of irreducibility criteria. So if we do not apply that definition, or we apply directly some test, then we will get the easy answer, because we have limited time and we have to solve this example in a limited time. So that's why we have to apply some short trick, definition, or some standard results. Okay, so now here I'm having polynomial here. Now let me explain Einstein's irreducibility criteria here to apply for our function. Now what we do, we find first prime number p that can divide our polynomial. Okay, but which cannot divide nth number, which square cannot divide first number. Okay, so here my first polynomial here f of x is x cube plus 312x plus 123. Okay, so we can see that some of the terms from our polynomial is absent here. Okay, we have to complete all this term first. So x cube as it is here, the x square term is not present, so I written here 0x square plus 312x plus 123. Okay, so I got the a01, a2, a01, a1 0, a2 312 and a3 123. Okay, now find out the prime number which can divide this number. Okay, and we can see that here we have a0, a1, a2 and a3 here. Okay, don't go this direction. If you go through this direction, you will land on a0 which is equal to 1, but a0 is always coefficient. We do not have its coefficient x. Okay, so we have coefficient of nth term is a0. Okay, so that's why we have to take it is from this direction. So take first element 123, find out the prime number p. So I selected prime number p as a 3. So prime number p as a 3, so a0 123 divided by 3. Okay, so if it get divided by 3, then we'll get the 41041. Okay, so it's easier division that you may find it easily. Okay, now second a1 312. Now 312 also get divided by 3. It is also easier division that you can do. Again a3 also a0, a1, a2 is equal to 0 also divided by 3. That means 0 by 3 which is exist. Okay, so 0 by 3 also exist here. So a0 by 3 which is also exist. But an, what is an which is equal to 1, and by the definition of Einstein's irreducibility criteria, an cannot divided by any number, like whatever we consider prime number here. Okay, so I consider prime as a p as a 3. So an 1 cannot divided by 3 or divisible by 3. Okay, so 3 cannot divide 1. So the condition for last, an does not divide by p, it holds here. And one more condition, a0 does not divided by p square. Okay, so 123 cannot divided by p square means 9. Okay, 9 cannot divide this number. If this condition holds, then we say that our f of x is irreducible over q. Okay, so this is the only test we have to apply here in order to check our polynomial is irreducible over q or not. Okay, so how easy these questions are. Just we have to apply some definition. So one of the result here that can give us very easy answer. I hope you all have understood this lecture, which is a question which is based on CSIR NET exam. and very easy example. Even after, if you found any doubt, difficulty, let me know in a comment section. I will come up with some of videos with your doubts, difficulty. Okay, so thank you everyone, thank you for my today's lecture.